Good day, everyone. Today we are going to work on equations, tables, and graphs, Chapter 3, Lesson 5. First thing I have up here is something that may or may not be familiar with you in number 1. It is y equals mx plus b, and we're going to talk about this. This is technically, if we go down to the asterisk here, this equation is called slope intercept, or we could also call it y-intercept. And then these are equations. So this is the slope-intercept equation or a y-intercept equation. And trust me, when you get to know what y equals mx plus b is, which you're going to hopefully after this lesson, it's going to make graphing a lot easier for you and reading graphs a lot easier for you too. You have to bear with me here for a couple of minutes. I'm going to identify what each of the variables represent in this generic equation, y equals mx plus b. We'll start with y. Y, as you know from our earlier lessons, is the output. Y again would be the second part of an ordered pair, the second coordinate or the second number in an ordered pair. You also know y from our earlier work as f of x, and you also know y as the domain. We're going to go down to x here. X is going to be our input. I'm sorry, it is not the domain here. Y is the range. X is the input. X is the domain. X is also the first coordinate in the ordered pair when you write an ordered pair x, y. M is our slope, which is going to be brand new to us. We're going to talk about what slope means, and I know you've seen or heard of this before. And then B is going to be our y-intercept, which again, some of you may know this, some of you may not know this, but even if you do, we're hoping to take it a little bit further than what we have in the past. So, y and x I think we're pretty good with. We're going to talk a little bit more about what slope is and how we identify slope or what slope is referred to. It is really, on a graph, it is the rise over the run. Slope is rise over run, and we'll talk about what that is. Slope is represented with the variable m, as you can see up in our slope-intercept equation. Another way of identifying slope would be the change in y coordinates, or in y points. We're just going to say the change in y for now, and we'll explain here in a little bit, over the change in x. Change in y over the change in x. And then we're going to write this. So another way of writing this would be the first y, or a y in your ordered pair, minus a different y in your ordered pair. And we're going to put that over top. The x that corresponds with the first y over the x that corresponds with the second y in an ordered pair. And again, all of this is pretty technical stuff. It would be probably really good for you to come back and watch this after you see the examples. And it should hopefully make more sense to you, and then especially after we get done with our work. The y-intercept. How do we identify what the y-intercept is? The y-intercept is where x equals 0. So in an ordered pair, wherever x is 0, whatever the coordinate is for y, that is called the y-intercept. In our equation above, in number 1, we called it b. The y-intercept is b. So it's also referred to as the letter B. And then if you're looking at a graph, the y-intercept is where your graph crosses the y-axis. Hence, y-intercept, we call it y-cross, but it's where the graph crosses the y-axis. So there's all of our technical jargon. Again, you probably, when we're doing these examples, might want to come back and take a look at this information. It will make more sense after you see a few of our examples. And we're going to move on to example number 1. It says, write a function and graph it using the data table. Now I'm going to be pretty sloppy in how I'm doing this because I don't have a lot of room to work with. So I am going to actually show my work over here, and then I'll graph it on the graph. So we got write a function and graph it using the data table. We know that y equals m x plus b from our equation. I always recommend for kids to start off by finding the y-intercept. And as you know from back in our notes that we just talked about, the y-intercept is b, and the y-intercept is where your graph crosses the x-axis or where x is 0. On a problem like this, it's a little bit more helpful to find where x is 0. We see that x is 0, where y is -1. So we actually can write what b is. Y equals mx plus a -1, which when you have a plus and a minus, we know that it is a negative. So we actually have part of our equation written right now. Y equals mx minus 1. We have our inputs, we have our outputs, but we don't know our slope. So when you go back to our notes from earlier, you can see the slope is rise over run. It's represented with m. It's the change in y over the change in x. And the math part is the y1 minus y2 over x1 minus x2. I'll explain what that looks like here. When you look at your table, we have x coordinates and we have y coordinates. So we're going to start with the first one again, and we're going to do the change in y over the change in x. Okay, so we need 2 coordinates of y and 2 coordinates of x. So the change in y over the change in x, so now we're calculating slope, and slope is going to be the change in y over the change in x, and we said that would be y1 minus y2 over x1 minus x2. Okay, so we're just going to choose a y. We're going to choose a y, and we're going to choose the first one, which is -1, and we're going to call this y1. That's our first y. So we're going to put in for our equation right here, I'm just going to rewrite this equation with numbers now. It's going to be -1 minus a second y. And so I'm going to go down to my next y, and I'm going to use the number 0. Okay? And I'm going to put this over top of my x's. And my x's have to correspond with my y's. So y1, I use -1 for y1, so I have to use 0 for my x1. Okay, so this is going to be my first x. So it's going to be 0. And my x2, since this was my y2 that I wrote over in my equation, this is going to be my x2, and it's going to be 1. So we've got -1 minus 0 over 0 minus 1. -1 minus 0 is -1. 0 minus 1 is -1. -1 over -1 is a positive 1. And I now have my slope as a 1. So I can rewrite my entire y equals mx plus b as, and again, I'm kind of out of room here, y equals 1x minus 1. I have now figured out my y-intercept. I've now figured out my slope. With that information, let's graph. And we can actually graph using our data table. We're going to start with our first ordered pair of 0 and -1. We're going to go over 0, down 1. We're going to go over 1 and up 0 for our second one. Over 1, up 0. Our third one is over 2 and up 1, over 2 and up 1. And our last one is 3, 2, over 3 and up 2. Okay, I definitely have a function, as you know, because of the vertical line test and the fact that my inputs all have exactly one output. Good to go. Now, let's take a look at our equation y equals 1x minus 1 and see if our slope makes sense and our y-intercept makes sense. Okay, where does the graph cross the y-axis? Where does the graph cross the y-axis? This being the y-axis, it looks like it crosses it at this point right here, which is -1. Okay, -1 is my y-intercept. Good to go. My slope is 1. Prove it. We know from our notes that slope is rise over run. Slope is rise over run. So let's talk about what rise over run means. Let's start at any point on our graph. I'll start at this point right here. And let's rise up and run over to our next point. So if I start right here and I rise up 1 and run over 1, I have 1 over 1, which equals 1. Our slope is 1. If I start at the same point, that I started on my last rise over run, let's say I don't want to go to this point, I want to go to this point right here. So I'm going to rise 2 and run 2. So if I rise 2 and run 2, that's still 1. So no matter what, if you go from any point on your graph to any point on your graph, you're going to have a slope of 1. Next problem. Same thing. Use y equals mx plus b. I'm actually going to stop and not do this one. Use y equals mx plus b to graph your table. And last one I'm going to go through really quickly because our video is getting long. It says write a slope-intercept equation from the graph. So I know that my slope-intercept or my y-intercept equation is y equals mx plus b. Really simple. Let's always start with the y-intercept. The y-intercept is where the graph crosses the y-axis. Here's my y-axis. Here's where it crosses. That is at point 1. So I've got y equals mx plus 1. Okay? Slope. My slope is rise over run. I have points plotted on the graph. I have a point plotted here, and I have a point plotted here. So let's just do a rise and a run. I rose up 1, 2 spots, and I ran 1 spot. So my slope is 2 over 1, which equals 2. My final equation is y equals 2x plus 1. It says write a slope-intercept equation with the graph. Your variable is x, your variable is y that you're leaving because you're plugging in numbers for x in order to get numbers for y, or inputting numbers for the input to get the output or the answers for y. Good luck.